Hi everyone, in today's class we are going to discuss design of cross girder. See, the cross-sectional dimension of cross girder, it remains as such of what? Longitudinal girder. That is what? The self-weight of girder which is calculated as such of what? Design of what? Main girder. Assuming the girder to be 100 mm per meter of span, calculate first, that is the depth of the slab. Okay, that is what you have assumed the girder, it is what? 100 mm per meter of span. 100 multiplied by total span of the bridge, they have given it as 16 meter, and you will get it depth of girder as 1600 mm. Then you calculate depth of rib. Depth of rib, that will be equal to overall depth of the girder minus depth of the deck slab. You need to subtract it, then you will get it depth of the rib portion. You will get it as 1400 mm. Next you calculate width of, take it as width of the rib as 300 mm. Take width of the rib as 300 mm. Okay, then calculate width of rib per meter length, that is what your self weight of what? Cross girder. That is what? Weight of rib per meter length, that will be equal to width into depth into multiplied by its density, that is 0.3 into 0.14. Take the density as 24, you will get it as 10.08 kilonewton per meter. This weight of rib per meter length, it is nothing but, that is what? Self weight of cross girder. Self weight of cross girder. Self weight of the cross girder, it is what? 10.08 kilonewton meter. Observe this figure, that is what? Total dead load on the cross girder. Observe this figure. Okay, the cross girder, the self weight, it is going to apply in the form of a triangular shape. Okay, the center to center distance of the cross girder, take it as 3.5 meter, and the width take it as 3 meter. Okay, center to center distance, okay, of the cross girder, you need to consider in the range of 3.5 meter to 4 meter. I have considered it as 3.5 meter. And it is what? Center to center distance between the longitudinal girder, you have taken it as 3 meter. First step you need to calculate is what? That is dead load. Okay, that is dead load from slab. You need to calculate dead load from slab. That will be equal to this height of this triangular portion, it is what? Half of the width portion. Okay, the dead load from the slab, it will be what? 2 triangular portion, that is the self weight of the cross girder. Above that, dead load from the deck slab as well as the dead load from the wearing coat. That will be what? Your total dead load, that is dead load from the slab. That is twice into area of triangle plus dead load of slab plus dead load of wearing coat. Dead load of wearing coat. Substitute the value, that is twice into area of the triangle, it is half into, okay, sorry, it is should be multiplied by, okay, sorry, it is not plus, it is multiplied by, half into base value, it is 3, height value, it is 1.5, multiplied by dead load of slab, it is dead load of slab plus dead load of wearing coat. Dead load of slab, it is depth of the slab, it is 200 mm, that is 0.2 multiplied by density, that is 24, plus thickness of wearing coat, it is 80 mm, 0.08, take the density as 22. Okay, then calculate dead load from the slab, you will get it as 29.52 kilonewton. Okay, next you need to calculate, that is what, you need to convert this UDL, okay, converting this load, that is the dead load, in the form of a UDL, okay, converting this to UDL, that will be equal to what, that is dead load from the slab, that is 29.2, it should be divided by the span. The span is how much it is, 3 meter, okay, then you will get it as 9.84 kilonewton per meter. Okay, once you convert this to UDL, okay, then it will be, total load will be equal to, total dead load, it will be equal to what, sulfate of the cross girder, it is what, 10.08 plus this UDL value, that is 9.84, you will get it as 19.92 kilonewton per meter. This is what your total load. Next you need to calculate the reaction on cross girder. Reaction on cross girder. Reaction on cross girder. The total dead load on the cross girder, it will be in the form of an UDL. That intensity of that UDL you have calculated, that is 19.92 kilonewton per meter. Then span it is 3 meter and 3 meter. The reaction at the support A it is RA and the reaction at the support B it is RB. Okay, then calculate, that is the reaction on the cross girder. The reaction on the cross girder will be what, your dead load shear force. Okay, in order to calculate, that is the reaction on the cross girder, that is RA and RB, you need to apply, that is the conditions of equilibrium. First conditions of equilibrium, that is summation V equals to 0, that is RA plus RB, upward is positive, RA plus RB, that will be equal to 19.92 into 6. Then it will be equal to RA plus RB, that will be equal to 119.52 kilonewton. Call this as equation 1. Then take moment of these forces about A point. Okay, then RB into 6, that will be equal to 19.92 into 6 divided by 2. Then you will get it as RB value as 59.76 kilonewton. Similarly, calculate the reaction RA value. You will get it as RA as 59.76 kilonewton. This is your RA and RB value. Now the reaction on the cross girder will be your what? Dead load shear force value on the cross girder. So dead load shear force value will be equal to 59.76 kilonewton. Next is live load bending moment and shear force. That is the live load shear force. In order to calculate, that is live load bending moment as well as live load shear force, the maximum live load bending moment and shear force for class AA loading will occur for the position of load as shown in the figure. Observe this figure. That is what cross girder spacing, it is 3.5 meter. Okay. Next is what width of that is center to center distance between the girder, that is the span, it is 3 meter as well as the 3 meter. You need to place the wheel. See here, the maximum live load bending moment and the shear force will occur for the position of the load itself. Okay, it is what they have specified, that is class AA loading. Okay, then effective length of the load as per IRC 6, it is 3.6 meter. Okay, then off of that it will be 1.8 and 1.8. Place the wheel load in between the inner girder, and this will be your, that is the cross girder. Okay, then center to center distance between the wheel as per the IRC 6, it is 2.05 meter, and the remaining distance it will be what, off of the 2.05 it will be what, 1.025. From that 3 meter, if you subtract 1.025, you will get it as 1.975. Okay, observe here, this is what the reaction, that is Rx and Ry. Place the wheel load. Okay, that is shear force value, that is 245 kilonewton, and this is 245 kilonewton. Center to center distance of the wheel, it is 2.05 meter. Okay, same you project it. Okay, that is the wheel load and this is the wheel load. Okay, how you will get it 245 kilonewton, I will show you in the next step and all. Okay, this is the wheel load. This is 1.975 and this is 1.975, and the distance between these two is off of the 2.05 value, that is 1.025 and 1.025. Maximum load transferred to the cross girder will be equal to the maximum load transferred to the cross girder will be equal to twice the weight of the one wheel divided by 2 into the spacing of the cross girder minus effective length of the wheel, off of the effective length of the wheel. Okay, that is effective length of wheel by 2 whole divided by the spacing of the cross girder, that will be your depth. Substitute here 2 into W value it is, that is total wheel load for IRC class AA tracked vehicle, it is 700. Okay, off of that wheel it is what, 350. Okay, 350 divided by 2 into, okay, that is what, the spacing of that cross girder depth we have considered it as 3.5 minus, okay, that is effective length of wheel, off of that effective length of the wheel, it will be 1.8 divided by 2, you can write it here, off of effective length of the wheel. Off of the effective length of the wheel means it is what, 1.8 divided by 2 whole divided by, that is 3.5. Okay, you will get it as 260 kilonewton. 260 kilonewton. Next you need to assuming equal sharing, the reaction from longitudinal girder, will be equal to, that is what, maximum load transfer to the cross girder. How many number of cross girder? It is 2. Okay, divided by number of girders. Okay, that is 260 into 2 divided by number of girders, it is 3. Okay, you will get it as 173.33 kilonewton. Then you need to calculate live load shear force with impact. live load shear force with impact that will be equal to, take impact as 10%, then it will be 1.1 into 173.33, you will get it as 190.66 kilonewton. This is what your live load shear force value with impact factor. Next is what live load bending moment in the cross girder will be developed below the load itself. That is what live load bending moment including impact factor it is calculated. Okay, you can observe here from the above figure which I have shown it earlier. Okay, that is where the wheel load it is placed, right? Exactly at that point the live load bending moment in the cross girder will be developed, okay, at a distance of 1.975. You can observe in this figure, okay, the live load bending moment will be maximum at the load itself. Load itself means this is the wheel load. Okay, at this point you need to consider a section and you need to calculate, that is the live load bending moment, okay, at a distance of 1.975 meter including what? Impact factor. Where the wheel load it is acting, at that point you need to consider a section and you need to calculate live load bending moment. Okay, calculated. Okay, the magnitude of this reaction on this longitudinal girder you have calculated, that is 173.33 kilonewton. Take moment of this reaction with respect to x-axis line. Okay, that will be your what? Live load bending moment with impact factor, that is 173.33 into 1.975. It should be multiplied by impact factor 1.1. Then you will get it as 376.56 kilonewton meter. This is what your live load bending moment, okay, in the cross girder which is going to develop including impact factor. Next you need to calculate dead load bending moment. Okay, dead load bending moment will be maximum at a location where the live load is maximum. Okay, calculate that is dead load bending moment at a distance of 1.975 from support. Okay, from support. Okay, observe this figure, I will write it. Okay, that is what this is A as well as B point. Okay, while calculating that is dead load shear force, that support diagram, that is the load diagram I wrote it, right? That load diagram you need to consider. Intensity of this UDL, it is 19.92 kilonewton per meter. Okay, that is the reaction value, it is 59.76 kilonewton you have calculated. You need to consider that is the dead load bending moment at a distance of what? 1.975 meter. Take moment of all the forces at a distance of 1.975. That will be your what? Dead load bending moment, okay, from support. Calculate it. Okay, that is, take moment of this force with respect to the section, that is x. It will be 59.76 multiplied by 1.975, that is clockwise. Next minus this UDL portion, 19.92 into 1.975, okay, into 1.975 divided by 2. Then you will get it dead load bending moment as 79.17 kilonewton meter. This is what your dead load bending moment. Okay, then you calculate design bending moment as well as shear force. Design bending moment will be equal to, add both the live load as well as dead load bending moment. Okay, that is live load bending moment you have calculated, that is 376.56 plus that is dead load bending moment you have calculated 79.17, that will be equal to 455.73 kilonewton meter. Similarly, calculate design shear force. Design shear force, that will be equal to, okay, that is 190.66 plus dead load shear force. This is live load shear force value, and the dead load shear force value, it is what, 59.76. You will get it as 250.42 kilonewton. Okay, next is what, the moments as well as shear force. Okay, observe here the design bending moment as well as the shear force value. These values are being very lesser in magnitude comparatively, so therefore directly you can assume that is the dia of the bar, okay, that is providing compared to what you are in the, that is the main girder, that is bending moment as well as the shear force value. Okay, in this cross girder, design bending moment as well as the shear force value, it is comparatively less, therefore provide 4 bars of 25 mm dia at top and bottom, with 10 mm dia stirrups. Okay, 10 mm dia stirrups at 200 mm center to center. 200 mm center to center. This is the longitudinal section of this crossbar. These are all the vertical stirrups. Okay, you are going to provide it as such of 4 bars of 25 mm. At the bottom 3 and at the top 1. These are all the vertical stirrups. Dia you assumed as 10 mm dia 200 mm center to center, and the main bar, it is 4 bars of 25 mm dia. Thank you.